Isaac. Tiger Wheel Sessions, 26th of January, session 11. What's up?
Hey, Aaron. I believe last we left off, we had finished our initial segmented linked list or unrolled linked list implementation, segmented array, and we're just about to write some tests. And we also just finished writing the NodePool, which was pretty short. So I guess that's what we'll be getting back into.
Yeah,
Give me a second, I'll share my screen, and we'll jump into it.
yeah, let's go for it.
Oh, wrong font size. Yeah, I also just rebased our branch onto the block reset stuff that DJ got merged yesterday, so we don't have any conflicts there.
Okay,
Um,
great.
and then we've got, this hasn't gotten pushed yet. I forgot about that. But yeah, we've got
Nice.
here locally, we've got just this NodePool stuff. Then we've got also the remove implementations. We should probably commit this stuff before we keep on working, I guess.
Yeah,
Just do one commit for remove and then one for the NodePool stuff, I guess. I don't know why it's not giving me tab completion there. Anyhow, um, just segmented array. Array implement move. I think I'll just leave it at that. And then this can go over to my other screen. And we've got one more commit to do for the NodePool. Then we're ready to go. Well, actually, is this done? We should probably check this over again since we did it very fast.
yeah. I think that's a good place to do some review.
Cool. Let's do that to start with then. So we've just got a buffer. We lined it to U122, the line of U128, so 16, in order to assure we don't need to do any align casts later on. And every node will be aligned to that. We could say that node size must be divisible by this then, to make sure that all the nodes are actually divisible by that as well.
Yeah,
Um,
that would be good. I don't know if we want to expose the maximum alignment alongside node size as a comp time argument. So we
we could,
pass
yeah.
in that once and then we use it in all three places. That way
Yeah,
the user
we can do that.
decides. Yeah.
Um, I think currently uses a U29 for this, but that's
Yeah.
only because LLVM uses that type.
Yeah. We,
Um,
we can
it's
go a
kind of
little
weird. We should probably
smaller. Yeah. We could do like um a U7 will give us 128 byte alignment. Maybe we want to do,
we only care about up to 16 byte alignment, I think, for this. I don't think it
yeah.
makes sense to have more. Because for normal types, if you're not doing like direct IO, you only need that really. The
Yeah.
other type is gonna have more alignment than that.
Yeah. Direct IO, then we might go up to 496 and that's all we need. So like a U12 would be
Right.
enough. U12 would be the biggest.
I think we should just use like a comp time inf there really.
Okay.
Or just I think we should just either just use that or yeah.
Okay. And one other U12, which gives us sort of what we would ever use in Tiger Beetle.
U12 was fine, I guess.
Yeah. Then
Um,
it's a bit stronger than comp time int because we know it's not signed.
yeah, that's true. Well, count time can be unsigned. That's right.
Yeah,
I guess this is better. That gives you maximum 49.6 alignment. Do we ever
yeah.
gonna use that for the node pool though?
We might like for some stuff, but I think it's reasonable. We might go up there, and I don't think we would ever go beyond that. Then it's not really needed.
I'm not sure we're ever gonna even use that for the node pool. Maybe we
No,
do when we write the stuff to disk. I don't know.
yeah.
Like, are we gonna? We could just write this stuff directly from these buffers to disks, I guess. So that might actually make sense eventually. So cool. Let's do that. That means is our node size gonna be divisible by that? I'm not even sure. Um,
Uh, it should be, yeah. We can just make it super strict here and then always loosen it later.
yeah, it is. Okay, cool. All right.
Cool.
And this is no longer a line of view with 128, but instead, um,
And we could do just some quick asserts up top also. Say node size greater than 0, alignment greater than 0. Because if we ever got those values, it just wouldn't make sense. And then we could also do um, say that alignment must be a power of 2. And we could do that on node size as well, just to make it explicit, although we did get it through the mod.
sure,
Yeah, awesome. Shall we bump the power of 2 check on node size just above alignment so we keep it in the argument order?
sure.
Yeah.
Or did you want to like do node size stuff first and then alignment stuff? Is that what you wanted?
I think how you've got it is good. We can do the greater than 0 checks first, do the power of 2 checks together. But I think we should do the greater than 0 first, otherwise the power of 2 will already fail.
Okay,
Just like that, yeah.
like
Perfect.
this.
Yep, yeah.
Cool.
I think that's it. Like, there's nothing else we could do there. What do you think? Anything else?
Yeah, I don't see anything else there. That seems all good.
Yeah. This is kind of like our usual operating space for all these structures. Like, we just limit power of twos, you know, yeah. Like
Yep,
EWAR as well, we made it very strict.
indeed.
Nice.
Okay, and then here we just do node size times node count to get size, allocate that much, half time
Okay.
node alignment.
Maybe, Isaac, here we could also do on node count some assertions at the top. Just say node count greater than 0, node count a power of 2.
Okay, do we know those things? I mean, no, greater than 0 is a no-brainer, of course.
Yeah.
Does the power of 2 make sense? I'm not sure it will be, to be honest.
Okay.
How do we calculate that? I think it's in manifest level. Node count. Oh, it's kind of inside the segmented array, it seems. Or table
Yeah.
count max. This is just like table count max divided by node size. Yeah, okay.
Okay.
Sort of.
But it's going to have a
This
plus
doesn't
1.
seem like the power of 2 exactly.
Yeah. Okay. So that's fine then.
Doesn't make sense that it needs to be either.
Yeah.
All right.
Okay. And then after that assertion, we can just add a blank line. Then we've got our preconditions grouped.
Yep.
Node size, node count, line size exact. It's nice, this alignment now coming all the way through everywhere. The init looks great. What do you think?
Seems good to me. Yep. Unit seems good too. These are the trickier ones, acquire and release, but particularly all these asserts here. But this
Yeah.
one seems pretty simple. Find the first free set bit. Find the first set bit which indicates that the corresponding index is free.
Okay.
And then we index using that index times node size to find the start of our buffer or our node or the node's buffer. We should call this node index to match what we do below.
Yeah.
Um,
Good.
well, there we go. Node size. Roll that buffered up point.
Ah, there's another check we could do here on the node pointer.
Yep.
We could
Oh,
check
the
that.
alignment's right.
Yeah.
Sure. Well, actually, that's the type system will check that though, because it's part of the type.
Yeah. We could
So
check.
this,
It's there. Yeah. We could check though that the index the node pointer less the start pointer of the buffer, that should be a multiple of the node size as well.
yeah,
Which,
that makes sense. I guess they can come third.
yeah.
Um, and well, we already do that because we do div exact here.
Ah, okay. Oh, of course. Yeah. Nice. Com time set.
Not really sure we need this assert, to be honest. It seems slightly redundant.
What are we trying to do with that one again?
Element or elem is going to be U8. It's like the child element of the slice type.
Okay.
And so we're asserting that U8 is equal to U8 because buffer works with U8s and nodes
Yeah.
are based on U8s.
Yeah. So we're kind of checking
That's
our
not.
own field layout anyway.
Yeah. I mean, if we do ever refactor this to like not use U8s for some reason, it would break this equation because you have to then multiply by the size of the type.
Yeah.
But I'm not sure well if we're going to do that. So
No, it's fine to have it here because we're doing like
yeah,
pointer arithmetic and we want to be sure we're working in terms of the same unit.
yeah,
Then that's good. Can rather over assert and that's not a problem.
yeah.
We
I
can,
agree. It's not bad.
yeah,
Actually, can make it a little bit slightly less verbose. I feel like just getting the STDs out of there makes everything more readable for me. It's just like there's less noise, and I'm what I'm like looking at.
yeah.
And so even if there's only like one in the file, I still do it. Um,
Cool, cool. I'll do that as well. And shall we add a
yeah.
comment just above that assertion and say we want to ensure that the pointer arithmetic is done in terms of the same unit?
Or this ensures.
Yeah,
And it's not even just the same unit. It's that um, we also need to do this for nodes. Well, node size we just have to rely on it, the fact that it's semantically in bytes.
yeah.
We're not even asserting that these are equal. We want to insert that they're equal to U8
Okay.
because well, we also want to assert that they're both equal. We want to assert that they're both equal to U8, I guess.
Yeah, that's even better. Yeah. Otherwise, we're only binding them to themselves, but we're not actually binding
Exactly.
them
And
to
then if
the
we change
unit
them
of
both
node
to
size.
U32, then it breaks.
Exactly.
Uh,
Yeah. Yeah.
And we can just say our pointer arithmetic here assumes U8.
Yeah. Yeah.
Assumes that the
We can say that the unit of node size is a U8. Assumes that the unit of node size is a U8.
yeah, I guess. Well, do we even care about these two then, or do we just care about node size?
Yeah, we kind of care about node size. So you see where we do pool.buffer.len, that bounds check depends on the size of the type. So we do need it to be a U8.
Okay.
Otherwise,
Yeah. So let's just put these first then, and
yeah. I've been
then
thinking,
just that is part of our assumptions for this function.
yeah. And because it's comp time, it's even happening before the precondition checks.
Yeah.
Yeah. Int node, pointer to int buffer pool, exact side, not be free already, and then set it back. I think that looks now 100%.
Cool. Yep, I'm happy with this.
Mm. If we go up to the top, Isaac, I was just wondering what fields do we have? We've got free and we've got buffer.
Just buffer and free. Yeah.
Okay, I was wondering if we had a field that we could use to assert when we de-init that it's only de-inited once, but that's not a, I don't think, I think it's fine.
Well, we'll get a use after free if we deinit this once. If we get deinit this twice, we'll get a use after free on buffer.
Yeah,
Which if we use the standard library allocator in the GPA in debug mode, it will get caught.
yeah,
Um,
yeah. No,
I'm not
that's,
too worried about that.
uh,
And this is set to undefined. It's also just freeze. It's just use it. This one actually would be fine for the second resize, or DNet, I think. You're just trying to resize to 0 again, but it's already at 0, so it wouldn't do anything.
yeah.
But yeah, that's not really worth doing anything
No,
further, I don't think.
no, no, I agree. Nice.
Shall we commit this then?
Yeah,
Um,
do you want to do a quick unit test for this?
sure. Yeah, we can do that. What are we gonna test? Do you want to first create a node pool or var? Um, what node size we want to use? Like use node size, 40, I don't know, 32.
Yeah.
Alignment 16. I'm not really sure we need to have alignment in the type. I think we should just have like a maximum alignment that we actually use, which might be 16. But it's not too bad. I don't like that you can like mix up these two numbers though.
Yeah, yeah, same. I it does mean though then that at least the user has to think of alignment when they use this. They can't just, it's not an
Yeah.
implicit internal thing.
It does make sense.
We could then provide it as like a named option. Uh,
Um,
but I'm not worried about mixing the order because also we've got two different types there. So
Yeah, we'll
all
probably get a compiler trying to pass the U size to here if we try and set the size like that.
yeah,
But these are comp time though, so maybe not. I don't know.
yeah,
We probably shouldn't have two comp time ints we're passing in. Like node size will be one of the arguments probably.
yeah,
Um, I feel like node size is always necessary, but alignment we could have like a default and have like an options thing. But I mean that's over engineering.
yeah.
Um,
I think this is good. Just like this, we
all right.
know we've done enough that it's not implicit, and then but we're not going further into like a lot. It's still like a
Yep.
sharp tool.
All right. What do we want to test here now? So all we can do is set and or we can always only just acquire and release things.
Yeah.
Um,
I thought we could do like a fuzz test where we have our own bit set and we basically call acquire we call acquire get something and we set our corresponding bit. Oh, but we don't actually know the index, so we can't really do that. Basically to do different patterns of acquire release and then check. Oh, what we could do is we could
yeah,
uh,
we could stick the pointers in a hash map and see that they're not the same.
okay, that'll work. Yeah, that's all we need actually.
Yeah.
Yeah,
There. Let's make a hash map. Our pointer map equals let's see that auto hash map, and we're gonna map it from a node. It'll be, I guess we can make our node type here.
we could call it
Pool
nodes. Oh, okay, cool. Pool.
node, or call it like test pool. I don't know.
Yeah,
And here is going to be test pool.node node, and we don't need to map to anything, do we? Just void. It'll also be like a
yeah,
hash set is how we use this.
yeah, exactly. Yeah,
Init, let's see, testing.allocator, and then defer pointer map.dinit. Just use the managed version because since we're doing testing, it doesn't really matter.
yeah,
And then we're gonna basically just do pointer map.insert or try pointer map.insert. Actually, we want to kind of assert in a test that it doesn't exist yet.
yeah. And
Um,
and that what we get has got proper alignment.
yeah, well, yeah, we can do that too. But that's part of the type system, so I think that it's not really any real
Okay,
need to test that. It's kind of verified by the compiler.
okay.
Um, I want like, we should just use like, just use get or put, and then assert that it doesn't exist. That might be the best way to test this. Otherwise, put doesn't really return you if it was there or not.
Yeah.
And put no
Oh,
cover asserts, but we want not assert. Instead, we want to like do the testing expect thing.
okay.
Um, so I think the right way to do this is to do get or put, and then check the result and assert and testing expect that it doesn't exist.
Okay.
So
And
pointer map dot hit.
can't we use put no clubber because that'll just ensure that it doesn't exist.
Yeah, but we actually want to fail the test by returning an error from the test block instead of just failing an assertion, right?
Okay.
Um,
Okay. Okay. Good.
we're gonna try pointer map and get or put. Um, this returns so get our put result, which has key pointer, value pointer, and found existing. And so we want to get our put NodePool dot acquire. And then try testing dot expect not grp dot found existing, and then that's it. That's how we test that we were asserting one thing to the set, and then I guess we want to do that until we've inserted everything.
Yeah.
We need to actually pass a count here to init, don't we?
Yeah.
We just like hard code this, or let's kind of make it constant here, I guess. Const node count equals like 32 or 64.
Yep. And we could do node size as constant and alignment as constant as well, right up at the top, and then pass them all in.
Yeah, sure, yeah, and then we can kind of refactor this into a fuzzing function.
Yeah.
Node size equals 32, and then equals. Actually, we could rename our alignment variable to node align. I think that's kind of a bit nicer.
Okay. I think that's nice.
That.
Definitely. And we can even just call it node alignment in just to write it in full.
Okay. Just be nice and verbose like that.
Yeah.
These lines are getting a little bit long, but they're still under 100, so that's fine, I guess.
Yeah.
Node alignment. I kind of like it lines up better with the other things, but
Yeah, I
alignment
thought so.
is
I thought, yeah.
yeah. So here, and so we want to kind of just do this until we reach node count, I think. For I equals. So that will be our insert loop, and we'll always assert that we don't find anything. And then we can't really test a panic, so we can't test that it panics when it goes beyond this, but
No,
we'll just go beyond this.
that's okay.
And then do we want to just start, so now we filled it up, and then the simplest thing is just to start remove all of them and insert that they all are in our hash map.
Yeah. What we could do as well is we acquire a node, then we put it into our hash map, and then after that we actually make a random decision. Shall we immediately release it or not? Or we can generalize that. So maybe this would be better. So we acquire a node, then we put it in our hash map, and then we choose a random element from our hash map and release it back to the pool.
Yeah, okay.
But we also we make it a decision whether we do that. So it's two decisions.
Okay.
We decide, do we want to release something? If we do, choose something random, release it. And we might even want to do that for the acquire as well. But okay, that's we can get to that. And then we start keeping a runtime count of the actual stuff we've put in. Okay, well, our hash map gives that to us. So
Yeah. Exactly. That sounds like a much better test, yeah. So we need like an RNG thing then, a pseudo random number generator, and then we need just decide randomly after we put in something Are we always gonna like insert them in orders? Well, I guess we don't really know the order they get inserted in. We're always just gonna assert something and then expect that we get it back. So first of all, how do we test the release side of this? I think it's just try pointer map dot remove. I think remove already tells us if it gets removed. If there is an entry, it is deleted from. Well, that's got the wrong dot comment, I think.
Mm.
Is that really just wrong? Yeah, it's not returned from this function. It does return whether we remove it or not, though. So it'll return false if it doesn't get removed. Yeah, get index will return true if we find it, otherwise it will return false. Okay. To try testing expect pointer map dot remove. Well, it'll be like something in the pointer map. We want to remove a random thing though, right?
Yeah.
So we kind of just have to like choose a random entry in the pointer map and remove that.
Yeah.
Which means, how do we choose a random entry in the hash map? It seems like it'd almost be easier to like use the array hash map, and then you can just like choose a random index.
I was thinking that too. Yeah. That because that'll be
Where's the array
fast.
hash map?
It'll be faster as well because a hash map is sparse. So yeah, finding elements in there is yeah, OM.
Okay, so auto array hash map. Changing our mind here. Does this still have get or put? It better. It does.
Very cool.
Good. And we can now just access one unmanaged. One, where are you? We'll have here somewhere
The
just an
get or
array
put
of
result.
entries.
Okay.
Data list is what we have. It's a
Okay.
multi-row array list now. Okay. Do we have like a function to wrap that, or we're just expected to access it directly? We've got keys and values. Perfect.
Yeah.
The keys will just give us a slice of keys, and then we can index into that.
Yeah. Nice.
I hope I'm looking at the right version of this. I might not be. Um, I'm looking at the O.9 or post O.9.0 stuff right now. So let's go actually.
We're about to switch to that, so let's use it.
Sorry, I just closed our terminal for some reason.
Okay.
Cool. That's the right key binding. So we can just use this whatever it is right now then.
Yeah.
So this is the O.9 or slightly post O.9.0 stuff. I've actually been using like for my O.9 work, there's a really nice command on master. I'm not sure if you saw this that improved the compile time of the std.format stuff by a lot with the
Okay.
stage 1 compiler.
Oh,
And so
nice. Yeah.
it like cuts the build time of the compiler itself by a good chunk, like 30% or something.
Oh, awesome. I didn't see it. So I saw
And also, yeah, so that's
Andrew
pretty
on
nice.
Hacker News with Dnautics with Isaac. They were chatting about Zig format. That like there's a lot of code Andrew wants to clean up. Can we bother you for like 2 minutes? Yeah, sure. Sorry, Isaac. Just a second. I'll be out for 2 minutes. Okay.
Cool.
Should we call it like a 5 minute break?
Let's do that. Sure.
Awesome. Catch you now. Are we back?
All right, let's jump back into
Right.
it.
Thanks for
So,
that.
yeah, no problem. Okay, we just left off right here. We're converting to use an auto array hash map. That's still good. Okay, just my highlighting looked weird. Um, yeah, and so I think we've got, there's nothing to change here. Getter put will give us, we'll insert these things in order. Found existing cell behaves the same. Remove, well, let's see if this still exists. I think it doesn't. Uh, remove by key, remove by key generic, remove by index. Yeah, so we've got several options here. So what we really want to do is choose a random index and then do remove by index, I think. Um, so we need some random number generation too then. How do you do that again? Simulator, RNG.
Yeah.
Okay, this
Yeah.
one. Grab all of that. Cool. And then I'm just gonna do like a single remove. Then we can intersperse them and make it random when they when they happen.
Yeah. Nice.
So we want PRNG or just random
We'll
int fitting range or int. What's the functions we have here? Here's the random. So we want like int fitting or int uint less than is what we want. Okay, cool.
and to use the biased version, I think.
We want biased.
It doesn't have to be like totally accurate because
True.
the unbiased one can have exponential runtime, I think. Yeah.
I think you're right. Yeah.
Or not exponential runtime, but it's just exponentially distributed. I don't
The
but I
runtime
don't
is exponentially distributed. Yeah. If field
I
function.
don't and
Yeah.
we do
Cool.
actually want to sometimes use a true random generator like a stream cipher. We should be able to use that. So then just bias, just something that get yeah.
Cool. Bias is then fine. So random dot uint less than biased, and it's likely to be less than pointer map dot or pointer set really is what we should be calling this. We're not using it like a map.
Yeah. Yeah.
Um,
We could
node
we
set.
could even
That's
we
better.
could we
Node
could even
set.
just call it pointers or node
Well, it's
set
not
is cool.
pointers, it's nodes. I think we think
Yeah.
node set is good.
Yeah.
Um,
Okay. Okay.
dot
It is.
we want to see the capacity. What's the function for that? And I haven't used this one very often. I think it's just count. There we go. Same as the other one. Most of the stuff's same as the other one actually.
Yeah.
So we want less than count. And then we just want to store this const index equals that. And then we're going to do set.remove by index. And this should return us a bool. It's not giving me the definition. Key. Just returns void. That's too bad. Okay.
Yeah. Oh, that is
Remove by
bad.
key. Actually, well, it makes sense. It always has to remove something if we give it an index.
Yeah. Okay.
We
Yeah.
Can we like do any more asserts here though? I guess
I
we.
was I was thinking we could do something where we write to the memory of the node and play with that so that we can start to detect stuff as well. If we
Oh,
So
yeah.
as we release the node, we zero it out. As we acquire a node, we expect that it's zeroed, and then we immediately change it to a function of something random that isn't zero, so it's always different.
We could like hash the pointer or something. I don't know.
Yeah.
I mean, I think we just want to do a get here actually, and then pop removes. That's just last inserted. And these functions aren't even public. Remove by index and whatnot. Where are the public remove functions? Reindex, clone, swap remove at. Okay, here we have it. We got swap
Yeah.
remove at and ordered remove at. These are the ones we can actually use.
Okay.
Okay.
We don't, because it's a set, we don't mind about order.
Yeah.
So
We just
swap
want to be able
remove's
to
fine.
randomly remove things.
Yeah.
And so ordered remove gives us a bool. But we don't need the bool. We actually want to get the pointer out first. We actually want to remove returning the element that's being removed. I don't think I see an option for here. So we'll have to do like 2 lookups then, which is all right for a test. Or here we do fetch fetch remove index. There's no, it doesn't take an index though.
What,
We
why
want
do we need
fetch.
the, why do we need the,
We need to
if we're
remove it from
removing
the
it?
node set. We remove it from our set. We also need to remove it from the node pool or release it to the nodes pool when we remove it
Okay.
from our set, right?
Okay, of course.
Um,
Can't,
we need the pointer back. Fetch
okay.
swap remove. Yes, I'm not seeing remove the function that takes an index and returns us. What we want is like fetch swap remove at uses a size, but these fetch ones all take just a key. They don't take they don't take an index.
Mm.
So I think we just want to do first a get on the index, or we can just index into. If we've got the index, we can just do keys index. Okay, that works. Cool.
Yeah, nice.
Const node equals, yeah, I'm making this way too complicated. Set keys index, and then we can remove by index then, and we can
Expect
insert the
that's
node
true.
back into. Sorry?
Oh, sorry. When we remove by index, we need to just add that we expect it to be true
Actually, we can't do anything here because this
because it's
returns void, I
void.
believe.
Okay.
Um, that's also not what the function's called. This is called something else. Darn it. It was called, we wanted to just do swap remove, right?
Yeah.
That takes, where's the one that takes an index?
Swap remove at.
Swap remove at, there we go. Yep. So what's missing is fetch remove at kind of, but maybe that doesn't make sense because we already have the index. I guess that's what it
And
is. It just doesn't like
I
it's not really necessary because you already have this option that's also constant time.
yeah.
Remove or sorry, swap remove
Remove at.
at index, and this doesn't return anything. It's just void. Cool.
Yeah.
And then we need to then also remove it from our node pool. So node pool dot release.
Release.
Node. I think you're right. We can't do any checking here actually. We need to start writing something to the nodes to be able to check this. Like the one that the one we get back from our hash set hasn't been touched since we acquired it.
Yeah.
Yeah.
So
So
before we release it, we want to zero it out.
okay, we don't have to zero the whole thing though, just like the first. You really just do the first element probably. Or the
Yeah, I think zeroing the whole node is good because that way, if there's any overlap, we'll detect it.
okay.
Anyway. And then when we
I want to change the order here.
yeah, that's good. Cool. Then when we acquire, we want to do that as well. So maybe we can hoist NodePool acquire out to capture the node.
Yeah, we do need to do that.
And then once we've acquired it, we want to immediately write. I think what we want to do, what do you think, Isaac? Okay, well, no. Okay, so the index into the set is changing because we're using swap remove.
Yeah, so we can't use that. We could use like a hash, just like write the pointer address into the node. Um, well, actually that doesn't really work either. We could also just add some. We can make this a map instead of a set and have some ID here. We then we just generate something random and write that to the node and also into our set as the.
Yeah. And then what we do is we write that to the whole of the node, repeating it.
Okay. Yeah.
Yeah.
And so
And
it'd
I
just
think
be like a random
yeah,
byte maybe,
yeah,
or do you think?
yeah, exactly, just like that. And actually, like for this testing, I think we don't need to. We could play with the node size, but yeah, maybe we do. I was thinking we could even use a very small node size, like a U64 or something, and we
Yeah, we probably
generate that.
can. You just
Or
make
we
this
can
you can make
even,
this a U64 though.
yeah, and the node size as well can be a U64. So eight bytes. The problem with that then is that we're not really testing our alignment well enough.
Yeah, we can just write
Yeah,
copies of it throughout the whole node,
yeah,
and then do we really need copies throughout the whole node? I guess we do to test this thoroughly. Um,
yeah,
just make this like 32. I think that's fine. Let me just write it twice or four times. Um,
yeah. That's cool.
so I'm gonna get rid of this while loop for now because we don't. Let's just focus on. We're just gonna do like the insert. We're gonna figure out our insert and remove operations, and then we'll interleave them randomly.
Yeah,
But
yeah,
the tricky part's getting the two things figured out that we can test.
yeah.
Um, Cool. So now we're
So,
going to generate something random based on the node. So this
yeah,
is really
and
just get a
also,
random number. It doesn't need to be based on the node. So
yeah, it just needs like an ID for the node, and we put it in the hash map. And then when we release the node, we're going to check before we release it that the node's memory contents are as we expect.
yeah, so you just say random U64. I think that's right.
Yeah, that's right.
And then we're going to then do like mem.set
We can do bytes.
U64
Yeah, bytes
bytes
as
as
slice.
slice. Yeah. And slice. Boo. Node. Then yeah, ID. That's all that
Nice.
is. Then we want to get or put node. Now we need to update the value though. P dot value pointer dot star equals ID. Cool. I think that does it now.
And then we should just check after acquiring the node. We should test that the node's memory is all zeroed, that we haven't acquired something
Yes.
belonging to someone else.
Yep. Um, so we
Uh,
just like, what do we do here? We need to loop over the memory essentially.
yeah,
Or just mem dot
just
equal. That would be, yeah, just
we can have
or
we just sum up the byte, var sum, and at the end of the
we can
loop
just
we check
break as
that
soon as we
this
find a zero.
it's
We don't
faster
want
not
to
to.
overflow.
Yeah, but
Then you
it's
gotta deal with
faster not.
overflow though.
But you make the sum as a U64, and then you just you can actually just XOR the bytes, and then at the end you check that the the sum is
XOR
zero.
is good. Yeah.
Yeah,
So
yeah.
for node,
Or sorry, not
right.
XOR, union. Yeah,
Union, you mean like, yeah, bitwise or,
yeah. Because we just
yeah.
and that way it's actually pretty fast because it's branchless. We just go all the way through, and at the end we do the check.
We just do this byte by byte, I assume. Or actually, it'd be faster to do it as the word size, and then just use like bytes as slice. Or
Exactly. Yeah. Yeah. As a machine would.
just use U size here.
Yeah.
And then, whoops, grab that. And here we'll call it, instead of byte, we'll call it word. And then we'll do result equals word. And
Yeah.
then at the end, we're going to do testing.expect equal size 0 result.
We could actually call it words or sum. It's a
Not a
kind of
sum
sum.
though.
Yeah, it's kind of one. It's more like the value of the words, that all words are zero, because that is what
Or
this would check.
aggregate.
Aggregate. Yeah. Yeah.
I don't know how to spell that.
Yeah.
That seems to be right, actually. Nice.
Yeah. Yeah.
That's clever. Cool. This shouldn't be U64, it should be U size.
Yeah.
All right.
Even better.
Cool. Now we've got this done too. Yep, this all seems good.
Yeah.
You can kind of break this up a bit, maybe.
Yeah.
Actually, this could come also like after we do that. We could do that. And we have all the ID stuff together here.
Yeah,
And we got all this stuff. Okay, this seems good. Now we need to check when we release the node that we still have this thing.
exactly. Yeah.
Const ID equals node set. I need to change the name of that now to map, I guess. Values index. Should this be node map now?
Not bad. And it lines up nicely there.
Yeah, pretty well. Oh, it does. Yeah, here. And now we need to do, well, how do we do this for if we say, here's it's much simpler to just break if we don't find the ID.
Yeah. We can do a test expect on every word.
That's fine too, yeah. Yeah, I guess that's probably simplest. So for mem.bytes as slice u64 node, we're going to iterate over the, it's not words anymore, it's
It's ID
excuse me.
ID size.
Yeah, it's ID size, but that's not a very good name for the
Yeah.
you can just say chunk maybe. Go with that for a minute and see how it looks.
Yeah.
Try testing next. Oh, it's just ID and trunk.
Cool.
Cool. Yeah, this seems all good.
So it should be mirrored
Now,
now, that it should be symmetrical across the two, and then we have to just check. We need to keep track of how many things we've acquired, because if we've acquired up to our node count, then we can't go into the insert branch,
yeah, so
and we have to
here,
keep track of how many things we have, because if we've got 0, then we can't remove anything, because then node map UN
yeah,
less than
so
biased will be overflow.
if count um 0, well, that constant time return. I think we're gonna make these into two separate functions.
Yeah, nice.
Equals node count return. Let's do something like that. Nice and simple.
Yeah.
Is there an empty function? Maybe there is.
Hey, that'll be cool. Isaac, I've got to quickly head out, so shall we get back
All right.
in on the half hour in an hour and a half?
Sounds good to me. I'll see you then.
Yeah, so that'll be 10:30 UTC. Yeah, awesome.
Yep.
Great.
Cool.
Nice
Then.
work. Okay, bye.